one, that when you have a remainder, the divisor is part of your answer as well. You just don't write 6 as a remainder because it's 6 out of 11. One of the mistakes a lot of students make that I've seen lately, I hadn't seen this like back in the 80s and 90s when I was teaching, is that they write 71.6 as if this divisor out here was 10 and it was 6/10. The decimal that comes after this certainly depends on whatever you're dividing by. So this is how we'll be writing, at least for our algebraic purposes, the answer to a long division problem. Again, the answer is called the quotient. The number you divide by is called the divisor. And the number you're dividing is called the dividend. And this piece right here is called your remainder. Now, the nice thing about division is you can always check your division by saying your quotient times your divisor, 71 times 11, equals 787. And I did something that I can't believe I did. This is called a run-on equal sign. You can't write that. That's 781. Then you take 781 and you add 6 to it to get 787. Okay. So you know you did your division correctly and everything's kosher. Nobody had problems with this one. And then this one is to get you to use some of the ideas you know about long division with numbers to now apply it to algebra. If I tell you that this polynomial 2x cubed minus 3x squared minus 11x plus 6 can be evenly divided. Why am I saying can be evenly divided by x minus 3? How do I know it's evenly divided? I don't have any remainder, right? This first problem, 787 divided by 11, is not evenly divided by 11. Anytime you have a remainder, your divisor does not evenly divide into your dividend. So 11 is not a factor of 787. Here, because I have no remainder, I know that x minus 3 is already a factor of the dividend. So all I have to do now is take my answer, my quotient times my divisor is going to equal this, write it times x minus 3, and maybe it's already completely factored, maybe it is not already completely factored. So I look at my second factor here. It's a second degree polynomial expression. It's a quadratic expression. It's not anything to be solved. There's no equal signs here. And I say, are there factors of 2 and 2 that differ by 3? And the answer is yes, 4 and 1. So 2x times 2, that will give me 4x. And I want it to be a positive 4x, so when I put the minus 1 there, times 1x, I get my 3x in the middle. So there's my complete factorization. Okay. So we can say that all of these numbers truly are factors of this original polynomial. Now let me just ask you a question. Suppose I say I want to look at the graph of this, and I'm going to turn that dividend into a function. So there's the function. Can you tell me anything at all that you've learned from the last few days? Anything at all? I'm not going to ask you to graph this right now, but tell me anything at all about the graph of this function right here? Any piece, anything at all? From looking at the Moshe? So you're saying your end behavior is as x goes to negative infinity, this goes to negative infinity, and as x goes to positive infinity, that goes to positive infinity. Is that what you mean? Okay, that's what it sounded like. So I'm just going to put 2 arrows like this. Okay, there they are. That's my end behavior. I'm an odd function. My first coefficient 2 is positive, so my right arm's up. Okay, what else can we tell? Remember, you can write this like this as well. X minus 3, 2x minus 1, they're exactly the same, x plus 2. What else can you tell me? Right, so if you set each one of these equal to 0, you can find your zeros of your function, which relate to being the x-intercepts on your graph. So if x was 3 here, I get a 0. In this case, if x is 1/2, I get a 0. And in this case, if x is -2, I get a 0. Anything else I need to know? Just to do a quick sketch. Excuse me? Oh, yes, you're right, -1/2. Thank you. What's the y-intercept? 6. Okay, that's all I need. I go zoom, 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 something like that. Oh, what? This isn't right here?
No.
Why not? Why isn't that right?
Because if you have it there, and you have to go up, that would not make it.
Oh, so what did I do here at this 0 of -1/2? What was my error? It's supposed to go down because it has all of these zeros have multiplicities of 1, right? So, oh well, that didn't work. So I better pay attention to the multiplicities if I'm going to do this correctly. So let's try that again. All right, let's see. Maybe you can help me this time. Let's see, we've got a what? We've got a -2 out here. We've got a -1/2 right here. We have 0, 6. Are we right at 0, 6? Yep. Everybody agrees with that? 0, 6 for the y-intercept and a -3 out here. We know our end behaviors go like this. So what do you think? Yeah? Oh, someone just told me it was -1/2. I keep changing it. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. Whoops. Now I got to go back to positive 1/2. All right. So one of these days we'll get this sketch done. There we go. Now everybody in agreement? Are we okay now with our 3 zeros and our y-intercept? Okay, I know at this 0, my function, the value of my function, the output, the y values, whatever you want to say, have to go from being positive to negative to positive, because I cross here. Same is true here. I go from positive to negative. Here I go from negative to positive. And I don't care where your Humpty Dumps go here, your relative maxes and mins. You just want a quick sketch. So I just come up here, I'm heading, I know where I'm heading for, that y-intercept. I come down, and then I go back up. Okay? So that's what the sketch of that graph looks like. That's what we've learned in just a couple of days, is how to graph something like this without plotting a single point, really. Well, we plotted the y-intercept in our heads. Okay? All right, so today we're going to focus on long division, and we're going to start out first with one of the methods that most of us learned. And the only thing I did here is I took 11 and the number 787, and I divided it up into its place values. Because when we really look at a division problem, we're really looking at the biggest place value in your divisor and the biggest place value in your dividend. So here we're not going to pay attention to the +1, and we're not going to pay attention to the 10s and the 1s place just yet. We're just going to say, how many times does 10 go into 700? 7. 7 or 70? 70. And so where do we put the 7? Where do we put the 70? We put it right above its like place. So I'm going to move in one spot and put 70 there. Now I take the 70 and I multiply it by each of the terms, each of the place values here in my divisor. So I get 70 times 10 is 700, and 70 times 1 is 70. Is everybody with me so far? All right. Now the only thing I have to do is subtract. But notice, because I have two place values here, I have 10s and 1s, I have two terms here, so I must subtract both of them. So right now I have to change the sign on both of those terms. So in front of the 700, oops, that's not Why won't this change color? I guess I have to go up here. I put a negative 700, and this plus becomes a negative. So 700 take away 700 gives me 0, and that's good because I've taken as many of the 10s as I can into 700. And then 80 take away 70 gives me what? 10. Okay, I'm ready to move on. So I bring down my next term, my plus 7. And again, I only focus on the largest place value in my divisor and the largest place value in my dividend. How many times does 10 go into 10? Once. Notice where I place that plus 1, right above the ones place in my divisor. I always line up my like place values. Now I take 1 and I multiply it by 10 plus 1, and I get 10 plus 1. Now I have to subtract both of them, both the tens place and the ones place. So I subtract the 10 and I subtract that 1. This gives me 0. And what am I left with? My remainder. Okay, so my answer is 70 plus 1 plus 6 over 10 plus 1. Now, of course, we call that 71 6/11ths, but that's how we would write it if we wrote it out in with all of its places. Okay, is there any question on this process? Yep, Alex? I'm never going to ask you to do a long division with numbers on a quiz. No, what's coming up is what we're about to do now. Okay, so you'll see. All right. So now let's take this problem, which is an arithmetic problem, and let's change it to an algebra problem. And we can do that by letting x equal the number 10. So what would my divisor become instead of 10 plus 1? What would I have outside as my divisor? X plus 1. Now inside I have 7 times 100. 7 times 100 is equal to 7 times 10 squared. So what do I write inside as the first term of my dividend? 7x squared, because 10 is taking the, x is taking the place of 10. So I have 7x squared here. Plus I have 80, which is 8 times 10. And if x is taking the place of 10, how would I write 80? 8x. And 7 is 7. It would be 7 times 10 to the 0 if I wanted to write it that way, but I don't want to write it that way. Okay. So I'm going to start my process exactly the same, nothing different. Look, how many times does 10 divide into 700? How many times does x divide into 7x squared? Well, let's see. Here's 7x squared, and when I divide it by x, what's my answer? 7x. Notice I have one less power. I'm no longer a square, or I'm in the hundreds place. I'm now in the tens place. So I put my 7x, I line it up with the like place value. Now I'm going to do the same thing I did here. I took 70 and multiplied it by the 10 and 1. I take the 7x and I multiply it by the x and the 1. So 7x times x is 7x squared, and 7x times the plus 1 gives me 7x. Okay, now what's my next job? What do I have to do next? Subtract both of them, exactly. So I put a little subtraction there, and since that's a plus, I make it a subtraction. This goes to 0, which makes me very happy. And now I have 8x take away 7x, and that gives me 1x, right? And then I bring down my plus 7. Now I say, how many times does 1x go into 1x? Just once, yep. And I write that right above my ones place. And now I take my 1 and I multiply it by x plus 1, and I get x plus 1. And now, as Marissa said, I have to subtract both of them. So I'm going to give you colored pencils today so that you can literally, when you change the signs on those, you can actually see it. And there's your remainder 6. So my remainder is 6 over x plus 1, because that's the divisor. Okay, this is long division using algebraic expressions, a long division of polynomials. Do you see it follows exactly the same principles as long division? Now, I do want to point out to you that your book gives you another method. I saw Marissa using it on the board earlier. Your book gives you another method which I won't cover, and neither does Caitlin. But you're certainly welcome to use it if you want. It's called synthetic division. We're only going to cover the long division. So if you want to look in your book, some students like synthetic division. They think it's easier to use. Other people stick with the long division. So, you did it in your homework, synthetic? Okay. Oh, so you looked it up? Yeah. Okay. So so we say here that 11 is not a factor of 787, and we say x plus 1 is not a factor of 7x squared plus 8x plus 7. So let's take a look at one more problem. We're going to go through this. Then we're going to cover a really important factor theorem, a theorem called the factor theorem today, and then you'll have the rest of the class to work on it. So let's suppose we had to divide 6x squared plus 5x minus 6, and we want to divide it by 2x plus 3. So really what this is saying, folks, is something like, how many times does 23 go into 600 and something? If you think about x being the number 10, it's like 23 into a number that's about 640 something. Okay, that's really all it's saying. So you start with your 2x, your biggest place value, and you ask how many times does it go into the biggest place value of your dividend, which is 6x squared. So you say 6x squared divided by 2x gives me 3x. Now it's important where you place the 3x. Think of this as your hundreds column. Your 3x would be like in your tens place. So put it right above the like place value. So you put your 3x up here, and now you multiply 3x by each of these terms here. So someone want to tell me what I would write underneath 6x plus 5x minus 6? Would it? You take this and you multiply it by your divisor. Plus 9x. Okay, so Jen and Moshe are now turned off. Okay, someone else want to tell me the next step? Make them subtraction. So I put a subtraction there and a subtraction there. Okay, this goes to 0, and now what do I write? Negative 4x. Then you bring down your minus 6. Okay, Emily and Marissa. All right, turned off. Okay, now what? So plug it in. What, I plug it right in there? What do you mean by divide it into? Okay, so then which order am I dividing it now? Yeah, what am I actually dividing here? Negative 4x, the whole thing, or I'm dividing this like this? I think we just have to deal with one term at a time, or else it's really going to be hard. So we really just look at the biggest place value here with the biggest place value here. So negative 4x divided by positive 2x gives me negative 2. So I write up here negative 2. So that's Drew and Doug turned off. Someone else want to help me? 2, 4, 6, 8, 10, 11. All right, we got 3 folks left, or 5 folks left. So we take negative 2 and we multiply it by the divisor. And what do we get there, Dan? Negative 4x minus 6. And now what's my very last step? Change signs to what? To positive 4x. I change that. And this negative 6 to plus 6. And notice what I get. Whee! I'm happy. So what does that tell you? What does that information tell you? Huh? Not only is 3x minus 2 a factor, but what else, Jen? Right. So in other words, I could have given you this problem in the first couple of classes and asked you to factor that, and this would be its factorization. There you are. All right, so when you get 0 for your remainder, you're very happy you've just found a factor. So if you wanted to graph, that, if you set that equal to f of x, boom, right away you know two of your zeros, 2/3 and negative 3/2. You know where it's going to cross your x-axis when you set these two equal to 0. So that gives you some information right away for graphing. It's kind of cool. All right, polynomial long division, we know how to check it. Here's our dividend. This is just all in fancy algebra. Here's our dividend. And we have a divisor times our quotient. So in our case, let's write what each one of these were. So our dividend in this case was 6x squared. Here was our dividend, 6x squared plus 5x minus 6. And that was equal to, what was our divisor again? 2x plus 3? Is that the divisor? 2x plus 3 times 3x minus 2 plus our remainder. Our remainder here was 0. So whenever that happens, when the remainder is equal to 0, that tells us that 2x plus 3 evenly divides into our dividend, and therefore you create factors of your original dividend, in this case f of x. So let's see how we can use this information with our polynomials, factoring. Okay, so suppose the polynomial f has zeros at x equals -2. So we'll put a little -2 in there. +1 and 3, all with multiplicities of 1. So immediately I know in this factorization I can put 1s right there because all the factors are going to have multiplicity of 1 because they cross the x-axis. They go straight through, just like a line would. There's no wiggles like a cubic, okay? It doesn't bounce and go back in the same direction or go up in the same direction. So all three of those zeros have multiplicity of 1. So what do we know the factors of the function are? So if we work our way backwards, if x equals -2, and I want to know, this is telling me that this was a 0. So originally it came from something that looked like that. So how do I work that equation backwards to get 0? What could I do to both sides? Add 2, right? If I add 2 here and I add 2 here, I'd be back to the factor x plus 2. And I know that that's a 0 because when I put -2 in there, -2 plus 2 is 0. So my first factor looks like this. X, take away a -2. But what does x take away a -2 simplify to? X plus 2, right? So anytime I have a 0 that's a negative number, this subtraction that's always there, will change to an addition sign. Okay, could someone else give me another factor beside x plus 2? X minus 1, right. Since it's positive, you just throw it right in. Comes along for free. And x minus 3. All right. So, again, I can either look at the number of factors I have. How many factors do I have here? How many factors? 3. So that tells me my 4 if I count a, but a can distribute through. So I have 3 zeros. I know it has to be what kind of polynomial? Not quadratic, because the most number of zeros I can have for a quadratic is 2, right? According to what we learned on Monday. So what's the most number of zeros here? It's 3. How many relative maxes and mins do I have here? 2. And we know that n minus 1 equals the number of relative maxes and mins. So since n minus 1 is equal to 2, I solve this for n, I get 3. So what's the smallest degree this polynomial can be? Cubic. The smallest it can be is a cubic. It could be a 5th power or 7th power. Cubic. Does everything line up with what we know? Yep. The arms are going in different directions, so it must be an odd function. with the right arm going up, I know that my coefficient, my leading coefficient, which is sitting right here, must be what kind of number? What kind of number? Positive. So we know A must be positive. And your homework is not going to ask you to find A. It will just say, what do you know about it? And it's going to give you a choice between +1 and -1. So they're kind of making life a little easy for yourself. Okay, so here we know A could possibly be 1. All right, so here's where the factor theorem comes in. We're given these 3 zeros. So if x plus 2 is a factor of this polynomial, then we know f of -2 will make the polynomial equal to 0. If x minus 1 is a factor, then we know f of what is equal to 0? 1. Just look at your graph or look right at your factor to see what value of x would make it a 0. And then if x minus 3 is a factor, then f of what is equal to 0? 3. Okay. And of course, we can do vice versa. If f of -2 is 0, you know a factor automatically. What is it? X take away -2, which becomes x plus 2. If f of 1 is 0, then x take away a 1 is a 0. And f of 3 is a factor, then x take away 3. Excuse me, if f of 3 is a 0, then x minus 3. So this is how it's summarized. This is the big thing you're going to highlight in your notes today, because this is the big. All right. If f of x is any polynomial and we find a number c, so that when we plug it into our polynomial, it makes the polynomial equal to 0, then we say c is a 0 and x minus c is a factor of your polynomial. Now, of course, if c is a negative number, this will become x plus c. This is just the way we always write it in standard notation. If x minus c is a factor, then f of c, whatever c is, in the subtraction form. So if this was x plus 5, then c is equal to a -5. It would be f of -5 equals 0. So you want to always, before you start plugging numbers in, it has to be in this x take away c form. So for example, if I wanted to use the factor theorem to solve this equation, now notice I've set this equation equal to 0, and I've told you -2 is a 0. So what can you do with that? You can say f of -2 is a 0. Can you tell me what the factor is? The factor of this polynomial. X plus 2, thank you. Right? X plus 2 is a factor. So if you want to factor this and you know that x plus 2 is a factor, then all you have to do is factor it. You have to do your division. So let's do it. X plus 2, I think we can go pretty fast right now. Are all of my terms filled in from the highest power to the lowest power? Do I have anything I have to put a 0 in front of? I've got a third, a second, a first, and a constant. Oh, good. So no zeros are needed to hold my place value. All right. So now, x goes into 2x cubed. How many times does x go into 2x cubed? 2x squared. So I bump in 1 and put it above its like place value. So I'm going to put 2x squared right here. And now I multiply 2x squared times my divisor, 2x squared times my divisor, x plus 2, and that gives me 2x to the third plus 4x squared. And now I change the color of my pen or pencil because I have to subtract both of these. That gives me a 0. And now I have -3x squared take away 4x squared, which is -7x squared. So now I say, how many times does x go into -7x squared? And my answer is negative 7x. So right above my like place, I put negative 7x. And now I multiply negative 7x times x plus 2. And I get negative 7x squared minus 14x. And I write that down here. Negative 7x squared minus 14x. So I brought that down. And so let's see. Oh, excuse me. This is negative 11x. So I put in negative 7x squared minus 14x. I change the sign of both of my terms to their opposite. That becomes a plus and that becomes a plus. Woohoo, 0 goes there. Now I have 11x plus 14x. That gives me 3x. And now I ask myself, how many times does x go into 3x? And my answer is 3. So I put a plus 3 up there. And now I multiply 3 times x plus 2. Oops, I got to bring down this plus 6 first before I get going here. Okay. Now I multiply 3 times x plus 2, and I get 3x plus 6. And I say hallelujah, because when I put a subtraction there and a subtraction there, I get a nice big smiley face for my 0. And I'm almost done factoring that.
Wait, quick question.
Yep.
When you write 3x, why is it just 3 up at the top of the...
Because x goes into 3x 3 times. The x's cancel, okay? So now I've almost completely factored this. I have x plus 2 times 2x squared minus 7x plus 3. And now I have to factor this second factor right here. So over on my paper, I say I'm looking for factors of 2 and factors of 3 that add up to 7. That's not hard. The 2 is going to multiply the 3 to give me a 6. So I just put my parentheses here and put 2x, and I put my 3 way out there. That's my 6x. And all I have left here is 1. They're both negative, x plus 2. And now I've completely factored it. I now know 3 of my zeros. I know which direction my arms are going, my end behavior, and so I could get a quick sketch of this if I needed to. Okay, so you have 25 minutes to work on a bunch of these class activities to start putting the information together now for yourself. Please use your flags if you have any questions. I'll tell you real quickly before you leave, Dan, about this, Marco, about this new schedule, okay? First of all, for those of you who did fill out the survey as I had requested, I'd like to thank you for it. And some of you now have a privilege even by not filling it out based on your classmates' feedbacks. What I did, I read all of them, and one of the feedbacks that I saw, some of the feedback that I saw that was existing in both classes was people missing having a review day. So we have one test left. So if you look at your old schedule and this new one, I've taken out the quizzes to make them both take-homes to give us an extra day, so that you will now see on May 4th, you'll have a review before test number 3. Okay, so when you look at your quiz, you have to look to the outer column to see when your last 2 quizzes are. Again, if you do not show up on that day, regardless of the fact that I'm letting you take it home, it's still a 0. You must be in class to get it. So you will have a review before the 3rd test, and you also have a review before your final. Okay?